Hello, hello, and welcome to this video. And in this video, we will learn some basics of Python. So, if you remember, we had installed Python in last video. So, let's go to videos and Python 3 programming folder. Now, we don't need to create virtual environments and all because we will not be installing library for this playlist. So, we'll just work off what you call basic Python. So, let me open a file. Let's call it basics.py. Okay. So if you're writing scripts, then what you should do is your first line should be on Linux at least, or Unix or Mac. The first line should be something like this. Okay. What it does is that if you make the script executable, it will invoke Python 3 interpreter on your program. So the classical hello world program in Python is written like this: hello world. So you have print statement or print function rather, and you pass hello world in single quotes. In Python, you can have string within single quotes and double quotes. So string is a sequence of characters. Okay, if you're not natively aware of print, the audio bell is very irritating. But anyway, so suppose we have this program and we go to this, and to make it executable, we say chmod u plus x basics.py, and then you can do a /basics.py and hello world will be printed. Okay, so that's how we can print a string. Now, suppose we want to say that, suppose we want to print a number. So you say print and you say 5. If you want to print two numbers, we'll see that an example. So it prints 5. And let me comment this out. So comment you can do with a hash. The command will not be executed. Okay, you see 5. There are other ways to comment also with the multi-line comments and all. So suppose you want to print two numbers 5 and 10, then you say 5 comma 10. Okay. Now, that is the simplest way. There are other ways also, but it is the simplest way of printing two numbers. Okay. Now, suppose you want to do print a floating point number. Okay, a fractional number rather, not fractional, not rather, a fractional number. So 5.5, 10.10, those will be printed. Okay. So if you are coming from C and all, then you will see that I don't allocate memory or create variables in this case, but variables are needed, of course. Okay. Now let's see. So these are three basic types: integer, floats, and strings. Okay. Now suppose you want to print 2 plus 2. So how do you do that? You say print 2 plus 2. Okay. And then it will print 4. There you go. Print 4. Let me increase the font a bit for you guys to see in case you're watching on lower resolution. This is Fira Mono regular, and let me put it to 16, right? Okay, usually I don't work with such large fonts, just for the video. Now, once we have that, let's talk a bit about variables. So variables are variable names have another word for it. It is called identifier. Identifier means you associate a value to an identifier. It is used to identify something. An identifier is used to identify something. So what happens is when you say, let's take a value 5, and if you want to increase it, then you can't increase the literal, okay? And suppose you have to use further increase it, then you say 5 plus 1 plus 1 because you don't have 6, okay? But you can't say 6 plus 1 instead of 5 plus 1 plus 1, okay? I'll show you the problem, okay? Say, for example, we say 5 plus 1. Now we want to add one more to this 5 plus 1, okay? So the problem is you have to write like this. So a neat solution is you say x is equal to 5. And then you say x plus, you say after that, suppose you want to do 5 plus 1. So you say x plus, or I'll use a simple one. I will not use plus. So what it will do is it will calculate, it will put 5 here, and 5 plus 1, 6. 6 will be assigned to x. So you can say x, okay? And then you say x is equal to x plus 1 again. And then it will be x here. So it is much simpler. Now suppose in previous case you wanted to change 5 to 10. Then you will have to change at two places. Here you have to change at one place. So variables simplify a lot of stuff, okay? Plain and simple. You will find it very useful to have variables rather than literal values. Okay, so in case you want to see the output, I will show you 4, 11 and 12 because it was 10, so it became 11 and 12. Now variables can be lists, variables can be integers, it can be floating point, it can be a string, it can be a list. List is something which holds multiple values of heterogeneous type. It can hold an array. Array is basically multiple values with same type or heterogeneous type, homogeneous type. Heterogeneous means different. And then you can have, say, dictionary, which are key value pairs, or they are also known as associative arrays, variable. Basically, almost all values can have a variable name, okay? Now, how do we know that what name should be put? So the general rule for creating variables is that the recommendation is you use alphabets and numbers separated by underscore. Don't use anything else. Some symbols may be allowed. I don't know, remember the exact rule, but the general rule is that you use alphabets and numbers separated by underscore. So suppose we want a counter, then you should say my underscore counter. That should be your name. It should be by PEP8, that is the syntax recommendation of Python. It should be small letters underscore. If you have something at global level that we will see, it should be all capital. If it's a constant, it should be all capital. Global stuff should be all capital. So the general rule, always remember alphabets, numbers separated by underscore. For functions, that is also the rule. For class names, it should be camel case, that is capitalized words. Okay. So instead of my counter, if you are writing a class, you say my counter like this. Okay. So that is how you create the variable names. Okay. So we have variables, we have variable names. All right. In Python, we don't care about the memory address at all. Okay, we don't deal with that. Python manages memory for us by ref counting. We will learn how possibly learn later, a lot later in this, that what is ref counting. So now that we know we have variables, we have comments, we have floating point numbers. Now suppose x is equal to a, we say, okay. Now we say a, or rather this is wrong. We say a is equal to x. Now a is equal to x plus 1, or rather a is equal to a plus 1. So what will be the value of a? So as you can guess, this should be x. So what will be the value of a here? So x was 10 plus 2, 12. 1 here, so 11 and 12, and we say a is equal to 12 here, and here a should be 13. Okay. Now, does that change x? No, it won't change x. Okay. X will remain 12. As you can see at the bottom, x remains 12. So that is something you have to keep in mind. All right. So here a is a copy of x, and here a changes. All right. So we comment this out. What more can I talk about? Okay, one more thing I can talk about is, so suppose you will see that many programs do not have this first line. Okay, so how to run this program now? Let's say for some output this, how do we run this program? So now if you try to run it like this, it won't work. No, because now by default, the interpreter will be the bash shell, and bash shell can't execute Python script. So you can run it with the command. You type your Python executable name, that is Python 3, or on Windows py.exe or Python if you have Python as the interpreter. So we say basics.py, and then it will be printed. Okay. One more thing is that there's something called name of the script. So if you want, you can say print underscore underscore name. Okay, let's see what does it print. So it will always print underscore underscore main underscore underscore. That is the typical name for start or entry point for the program. Okay. Then there are built-ins underscore. I don't remember exactly. It is built-ins functions. Yep, built-ins. I think it's a function. No, it's just built-ins. So if you print built-ins, you will see, or I don't remember exactly. There is a function for built-ins or underscore underscore built-ins is there. Okay, I'll see what is the built-in. Let me type Python help built-ins. Built-ins. Built-ins dot. Okay, so these are your inbuilt stuff in Python. Okay, so for example, syntax error, for example, OS error, and all those things are there. So if you want to see that, what you can do is you can say import built-ins. Okay, if you want to see what is inside built-ins, and then you see this. Say n. Okay. So see, these are the stuff which are built-ins, right? There is a lot of thing which is built in. So all this you have to take care of. Now there is a problem here. Okay, I'll tell you what is the problem. You have to be aware of what keywords are allowed. Okay, that is one thing, because if you by mistake override keywords, but we will talk about keywords later. There are certain keywords, certain names, reserved you can't do. For example, you can have a variable print is equal to 10. Okay, and then if you try that, then this print won't print this. It's a problem. Okay, so certain names you can't use because they have their own meaning. You can't use a word like try, you can't use a word like catch, class, list, str. You should not use those names. So as you'll gain experience, you'll see. So I think I've talked about a lot of things, and I will let you process this information. So this is just the basics, basic stuff, and I'll see you in the next video, and we will discuss integer types more in detail, that what we can do with int. So an integer is not so simple. So if you want to know that what is the type of a variable, so I'll give you the shortcut is instance. If you invoke on X, for example, then it will tell you what is the is instance of not that type. The not is instance, it should be type. Okay. Now if you run this, then we'll tell you it's a class int. So we know that X is class int, but since Python is dynamically typed, you can say that X is equal to 5.8. And then if you see this type stuff, it will become float. So the type depends on the kind of value you store. All right. So one of the solutions of this is that let's say it is int, okay, and let's say this is float. Now we have a red line here. It is our RSP warning, okay. So you see, the problem is that it says that X is obscured by a declaration of the same name. So the problem is that it is int and it is float. So this float is overriding this int. So that is not a good thing. A red line is never a good thing. Okay. But it will still work. Python won't complain. Type hinting, this int is optional. We don't mandatorily need this. This is to ensure that your types are proper. That is, for example, let's say we have one variable and we have associated that with an integer. And then you don't want to associate that variable with a float because that is not a good practice. Because in a large program, suppose you have 10 X values and you go on using it. Then at different places, at different what you call scope levels, it will be difficult to figure out which X is being used. Okay. And you might remember when you're working on it. But suppose somebody comes to your file, he looks at the first declaration of X, which is an integer, and then he jumps to the last position where X is used. He will assume that it's an integer, but it might be an object of a class. So the general idea is to use type hinting, but don't worry about type hinting anymore. For right now, we will come to type hinting once we finish the typing module, which will be the part of standard library definition that is far, far away. That will come with the best practices stuff and all that. So I will end this video here and I will see you in the next video with the integer data type of Python. So thanks a lot for watching the video. Enjoy.